Okay, so what is a rational equation? So a rational equation, it contains rational expressions, which seems like, okay, that seems kind of like obvious, but what does that mean? Well, basically means that you have an equation where there are fractions and there are variables in the denominator of those fractions. So that's what makes something a rational equation. And the two big things when we're solving rational equations is that we always have to check to see what values are not allowed to be answers, or to make sure that our answers work. So unlike when you solve quadratic equations or linear equations where whatever answer you got was the answer, with a rational equation, sometimes you can get answers that are not real. They are extraneous solutions. And this is because when you have fractions, you can't have 0 in the denominator. So if you have a variable in the denominator, if you have a number for x and it makes that denominator 0, you can't have that as a solution. So we always have to check to make sure that none of our answers in the end make the denominator 0, because if they do, then they don't work, and so there is no solution at that point. So you always have to double check that you're not dividing by 0. The second thing when you're solving a rational equation is that you want to try to clear fractions. That's the whole point of solving, is to get rid of the fractions so that you have something easier to solve. So that's your goal when you're trying to solve these. And once you get rid of fractions, then it's going to look like an equation that you've solved before. It's either going to be linear or it's going to be quadratic. And once you get to that point, well, you guys know how to solve that because you've done that before. So the general steps for solving is to first factor. So I've mentioned this in like my introduction videos that we're going to be doing a lot of factoring. So the first thing you do is factor, because that's what we're going to use. We're going to use the factored form in order to find the common denominators. So once you factor, then you need to determine what the common denominators are. Once you determine that, then you multiply both sides of your equation by that common denominator so that it cancels out. It's very similar to when you were solving linear equations with denominators of numbers, where you'd multiply both sides by the common denominator to get rid of the fractions. It's the same exact process. We just have variables involved. Once you do that, you simplify as much as possible and solve. And then the very last step is that you then need to double check that your answers work and they don't make any denominator 0, because if they make a denominator 0, they're not going to work. So these are the general steps for solving. So whenever you see a rational equation, these are the steps that you're going to follow. So you're going to want to keep this handy, maybe print off this slide, whatever you need to do so that you have this somewhere so that you know what the process is. And the key is, if you see an equation, you need to be able to recognize and say, oh, I have fractions, or I have variables in the denominator. That makes it a rational equation. So I need to follow this step. So you have to be able to identify the type of equation so that you know what steps to do. So that's like the key here. So there are a couple different techniques for solving these. Basically, you're going to get the same answer no matter which way you go about it. It's just a matter of when you do certain steps. So the first technique is to try to get your equation into form where you have a fraction equal to another fraction, because then you have a proportion. So if it's like I have something on top of something else equal to something on top of something else. When you have a proportion where you have a fraction equal to another fraction, you can cross multiply, which means multiplying the diagonals. And so that is a technique used to solve proportions. You multiply and you set the diagonals equal to each other. And so that's one technique, is to try to put it in that form so that way you just multiply diagonals together. If you choose to use this technique, you may have to add or subtract fractions on one side or the other side. So the adding and subtracting that we did in section 4.1, you may have to do that in order to put this in the form that you want. And in order to do that, you do need to get a common denominator. So you're gonna be working with common denominators no matter what method that you use. There are certain types of equations that are better for using this technique than others. So if you have equations that already have common denominators, this is a good method to use for those. Or if you have ones where it's really easy to get a common denominator and to combine, these are a good method for these. So I'm going to just demonstrate this technique and go through the whole solving process here. So we have solve 3 over w minus 2 minus 6w over w plus 1 equals 6 over w plus 1. So this is a good candidate for using this method because we already have two things with a common denominator. So this is a good method to put it in some form where I can cross multiply. So what we do in order to do that is we want to make this fraction be on the same side as the other side with the other, so that the common denominators are on the same side. So I have a minus 6w over w plus 1. So I want to add that to both sides so that it's on the same side and the denominators that match are on the same side. So we're going to add 6w over w plus 1 to both sides. So when you do that, you end up with 3 over w minus 2 equals, I have my 6 over w plus 1 plus 6w over w plus 1. So now I've just moved it to the other side. Now if you have a common denominator like we do here, you can combine them by adding the tops of the fractions. So we'd be adding these together to combine it into a single fraction. So I have 3 over w minus 2, and then 6 and 6w are not like terms, so you're just literally writing them. You're just making one single fraction out of what you had already. So this, now we have a proportion because it's in the fraction equal a fraction. A fraction equal to another fraction. And so we want to cross multiply in order to solve this. So you're multiplying the diagonals together. And so I'm going to try to color code these. It doesn't matter which diagonal you do first. So let's say I multiply that diagonal. Now because these are not single numbers, I need to have parentheses around these to indicate that I'm multiplying those together. So I have w minus 2 and then times 6 plus 6w. Then the other diagonal is 3 times w plus 1. So when you're cross multiplying, you're multiplying your diagonals and setting them equal to each other. So now we don't have any fractions, and so now we're solving, and this is going to be a quadratic because we have to FOIL on the left. So first, w times 6 is going to give me 6w. Then the outside, w times 6w is going to give me 6w squared. Then on the inside, negative 2 times 6, so that's negative 12. And then negative 2 times 6w, and that's going to be a negative 12w. So I FOILed on the left. And then on the right, I also need to distribute. So I'm going to do 3 times w, which is 3w, and then 3 times 1, which is 3. So whenever you end up something, here we have something squared, so we have a quadratic. And whenever you have a quadratic, you need to make one side equal to 0. So our goal is equal 0. So I am going to first, I'm going to I'm going to combine like terms on the left before I start moving things. So I have 6w squared. Then I have 6w and a minus 12w here that I can combine. 6 minus 12 is negative 6, so I have negative 6w. Then I have my minus 12, and this equals 3w plus 3. Now the thing here is that solving these does take up a lot of space. You can see that I've already kind of run out of room here. I'm just make a little note here so that if you happen to like print this out or something like that. So continued on next slide. So we have 6w squared minus 6w minus 12 equals 3w plus 3. So that's where we're at so far. So I need to get everything all on one side. So I'm going to subtract my 3w from both sides, because I need to get one side equal to 0. And you can also, in the same step, subtract the 3 from both sides, so you can get one side equal to 0. So this gives us 6w squared. Then I have negative 6 minus 3, so that's negative 9w. Negative 12 minus 3 is negative 15. This equals 0. So now we have a quadratic equation, set equal to 0, so now we can solve this. First step is always to take out the GCF if there is one. So we are going to take, I should use the term factor. We do have a GCF. Factor out the GCF, because that will make it a whole lot easier for us to solve. So I can divide 3 out of the 6, the 9, and the 15. I can't divide 6 out. I can't divide anything bigger, but I can divide out a 3. So I'm going to put that in front and then divide each of my coefficients by 3. So 6 divided by 3 is 2, so I get 2w squared. 9 divided by 3 is 3, so that gives me negative 3w. 15 divided by 3 is 5, so I end up with a negative 5 equals 0. So I factored out the GCF. It's equal to 0. And so now I need to factor my quadratic that's in smaller form here if possible, or use the quadratic formula. So it's completely up to you. This one I'm going to use the quadratic formula on because this, or not the quadratic formula. I'm not going to use the quadratic formula. That's a lot of steps. I'm going to factor this one because the numbers are small, so it won't take too long. There's not a lot of possibilities if you're trying to like guess and check. So I've got my 3, and then I'm going to set up my factors here. So the front of each of these parentheses need to multiply to 2w squared. So my only choices are 2 and 1. So I have to have a 2w and a single w, because that's the only way to multiply to 2. The last terms I need to multiply to a negative 5. So the only thing that multiplies to 5 is 1 and 5. It's just a matter of where do I put it. And then I also have to take into account the signs. I'm going to have a positive and a negative. So I'm going to just kind of show the possibilities here. If I put 5 here, that would give me 2 times 5, which is 10. And then that's going to be too far away from what I want. So I just look at that and I say, okay, I'm trying to get a goal of negative 3 in the middle. So I don't want my 5 there. So I want my 5 here and my 1 here. So when I multiply the insides, that's 5w, and the outsides are 2w. I'm trying to get a negative 3, so I have to have a negative 5 and a positive 2w. So that needs to be minus 5 and a plus with the 1. And that will get me my negative 3w. So now I've factored that. So let me just erase my scratch work here. So now that I factored, we're still solving a quadratic at this point. So I need to set each factor equal to 0. Anything that has a variable needs to be set equal to 0. So the 3 in front doesn't matter. So I have 2w minus 5 equal to 0 and w plus 1 equal to 0. And now I'm going to solve these for w. So let's solve the first equation, 2w minus 5. So I'm going to add 5 to both sides. That gives me 2w equals 5. Then you divide both sides by 2, which gives us w equals 5 halves. So I'm not going to circle that yet because I do have to check these in the original equation before I decide that they are the answer. So I'm going to just leave that. Now I'm going to solve the w plus 1 equals 0. So I'm going to subtract 1. And that gives me w is equal to 1. So I've solved, my whole goal here was to solve. So let me go back to the original problem we started with. We were solving this equation, so we were looking for w. So I started by putting my like term like things on the same side, the common denominator on the same side. I cross multiplied because I had a proportion, and then I started solving a quadratic. Once I got w, I need to double check that these work in the denominators, because the denominators are not allowed to be 0. So my two denominators in my original equation I'll just write this up here. We have w minus 2, so that can't be 0. And then we have w plus 1. That is not allowed to be 0 either, because those are the bottoms of the fractions. And if we divide by 0, then we have undefined. So we can't have those equal to 0. So w minus 2 and w plus 1. Well, if you noticed, we set w plus 1 equal to 0. But we just determined that w plus 1 cannot equal to 0, because that makes that denominator 0. So you want another way to look at it. If you solved that, that tells you that w cannot be negative 1. And if you did the same thing with the top one, w can't be 2, because 2 minus 2 would give us 0. Negative 1 plus 1 would give us 0. We're dividing by 0. So these are called restricted values. And these were talked about when we were talking about like simplifying rational expressions. So we're not allowed to have 2 or negative 1, and we just, except that I wrote 1. I forgot my, let me rewrite this. 0 minus 1 is negative 1. I just solved and got negative 1. So that means that that is not a solution. That is excluded. That does not work. So our only solution here is w equals 5 over 2. Because one of our answers that we came up with, we're not allowed to have. It makes the denominator 0. Okay. So I have a second example here where I'm going to use this same technique, where I'm trying to get, my goal will be to get it as a proportion. So some people, before they do anything, like to figure out what values are restricted. And they like to look at the denominators first. It's up to you whether you look at it in the beginning or the end. So one of our denominators is x. So we can't have 0, because then we'd have 4 divided by 0. The denominator with 5 doesn't matter, because 5 is not 0. The other one is x minus 4. So x minus 4 can't be 0, which if you solved that for x, you can add 4 to both sides. That tells you x can't be 4. So when we're solving, we need to just make sure we don't get 0 and we don't get 4. If we don't get those numbers, we're okay. So unlike the previous example where we had things with the same denominator, we don't have anything that have a matching denominator here. But this one is easy enough to use technique 1 on because getting a common denominator between x and 5 is pretty easy. You multiply the first fraction by 5 and the second one by x. You just basically, multiply by the other's denominator. So I'm going to be multiplying the first fraction by 5, and you need to do this on the top and the bottom in order to get a common denominator. And then the second one by x. So that way they both have a denominator of 5x. So I'd have 4 times 5. So I'm going to get 20 over 5x minus, and then just 2 times x is 2x over 5x. And this equals x plus 2 over x minus 4. So if I'm going to use technique 1 where I need to have a fraction equals a fraction, I need to combine these together, these fractions. They have a common denominator, so I'm going to basically be rewriting this as one fraction, 20 minus 2x, and then the denominator is 5x. And then on the right, I still have x plus 2 and x minus 4. So I have a fraction equals a fraction, so now I can do the cross multiplication part. So I'm going to multiply the 5x by the x plus 2. So I'm going to just write that down. And x plus 2 has to be in parentheses because it's the whole thing. And then that is equal to the other diagonal, 20 minus 2x times x minus 4. So now I don't have any fractions. By doing this technique, you don't have any fractions. And so now we're going to solve for x. And the first step is to distribute, just like we were doing before. So I'm going to have 5x times x, which is 5x squared. And then 5x times 2, which gives us 10x. On the right, I have to FOIL. I have 20 times x, so that's 20x. 20 times negative 4 is negative 80. And then the inside is negative 2x times x is negative 2x squared. And then negative 2x times negative 4 is 8x. So we're going to do the same thing that we did before. We want to combine our like terms on the right side. So I have 5x squared plus 10x equals negative 2x squared. 20x plus 8x is 28x. And then minus 80. So we want to put everything on one side because we have a quadratic. As soon as you see that you have something squared, in order to solve this, you must have one side equal to 0. I like to have positive numbers in front of my x squared, so I'm going to move my things to the left. So I'm going to add the 2x to both sides. So then I stick with, or the 2x squared, sorry. I'm going to add 2x squared to both sides so I can stick with positive numbers. I'm going to subtract the 28x from both sides. And then I'm going to add the 80 to both sides. And this will get me one side equal to 0. So 6, 7, I get 7x squared. 10 minus 28 is negative 18x. Then plus 80 equals 0. So now I need to figure out how to solve this. Am I going to try to solve this by factoring? Am I going to try to do like the quadratic formula? I look at this and I say, as soon as I see a number like 80, I'm like, okay, that's going to be a lot of guessing and checking because that's pretty big. So in this case, I would choose to use the quadratic formula. Just because I don't know if it factors, because I look at it, if I don't, like I look at it and the numbers are big, it's just safer to do the quadratic formula. So that is what I am going to do. So if you do the quadratic formula, 7 is going to be A, negative 18 is B, and 80 is C. So we're going to use the quadratic formula, and I'm going to just do that over here. So we have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to start plugging in my numbers. So b is negative 18, and we have a negative b, so this is going to be a negative 18 plus or minus b squared, so I have negative 18 squared minus 4 times a, which is 7, and c, which is 80, and then in the denominator 2 times a, so that's 2 times 7. So I'm going to be definitely pulling my calculator out for this. So just in interest, because I don't have a lot of space here, I am going to do all of this in one step on my calculator. So I can do that as long as you have your parentheses all in the right spot, you can do that all in one step. So I'm going to do that. And so I'm going to have x equals negative cancels out. So I just end up with a positive 18. And then inside my square root, negative 18 squared minus 4 times 7 times 80 and I get a negative, which makes me really glad that I use the quadratic formula, because that negative inside the square root means we're going to have imaginary numbers, and that means it does not factor. And then I can also actually do the 2 times 7. I can do that as 14. So once I have that negative inside the square root, I know that I'm going to get an imaginary number. And let's see. So 1916 does not even reduce nicely. It doesn't. You can't take the square root of that. So you try to simplify that square root. So I'm going to just cheat for now because I don't have a lot of space here, and I'm going to just give you that this simplifies to 2 square root of 479i. So I'm going to just let you know, you can verify that on your own. I don't want to go through all the time here since this is focused on the rational equations, but you can see we're bringing up the complex numbers, the quadratic formulas, all those things are popping up here. So this gives me x equals 18 plus or minus 2 times the square root of 479i over 14. So I can split this up, do 18 over 14 plus or minus 2 times the square root of 479 over 14 and I. And you can see that I can do some reducing here. So the 18 over 14, I can divide those both by 2. So that would give me 9/7. And the 2 over the 14, I can cancel. And so I get something 9/7 plus or minus the square root of 479 over 7. So this came out pretty nasty. This is actually nastier than usual. So we get two answers here, a positive and a negative version, and these both work because, I mean, clearly our denominators, that's not going to make any of our denominators 0. So we do get two answers for this particular example. So are there any questions? I know I had to skip some steps with the quadratic formula and the negative stuff just because I'm interest of time and space. But for the actual, like the process of the solving, do you guys have any questions? Okay. So that's technique 1, where you're trying to put it in a form where you can cross multiply, and then that eliminates your fractions, and then you can go and solve, and it's going to turn into a problem that we have solved previously, or a type of problem that we've solved previously. Technique 2 is a little more complicated. So this is where your goal, instead of getting a fraction equal to a fraction, your goal is to get a common denominator on everything. And there's multiple orders that you can do this. So some people, they find the common denominator, but never actually do the math to get the common denominator, and they try to do that in their head and skip that step. So that's what it means by multiplying by the LCD immediately. LCD is least common denominator. Some people will build the common denominator so they can actually visualize it and then multiply everything by that denominator to cancel it out. Some people will get a common denominator and then combine them and then multiply by the common denominator. So that's sort of similar to what we did in technique 1, where we got a common denominator, we combined them together, then we multiplied. And then some people will do that method, but maybe they might only do it on one side and not on both sides, and they could do a proportion method, sort of doing what we just did. So there's variations of the same idea here. So it can get confusing, so I try to make a tree of the different possible branches that you can do, and you'll solve and get the same answer. So let me just break this down to you so you can kind of see. So let's say we have this problem, same thing that we just did, the 4 over x minus 2/5, you know that thing. So we just solved it one way. One way is to determine that your common denominator on both sides would be 5 times x times the x minus 4, because those are the three different denominators, so that would be your common denominator. So when you determine that, one option is to multiply both sides by that denominator, and then to distribute across your fractions. And so when you do that, you end up with this that I have underneath. Let's see if I can laser point. No, I can't do a laser pointer. And well, I was hoping I can zoom in. So if you distribute the common denominator through, you get this nasty looking thing. And then if you simplify by canceling things out, you end up here. So that is one method. Some people do that. I don't recommend doing that because it's prone to errors. Second method is you're still trying to get a common denominator, but you're building that common denominator up first. So this is similar to what we did, but we did it basically on one side. And this would be getting a common denominator for everything. So we did it with just the x and the 5. Here it's using both sides. So I'm going to zoom in again here so that you can see that. So you can see that instead of just multiplying like the first one by 5 and the other one by x, you're having to include the x minus 4 as well. From there, you have two choices. So you can then multiply by that denominator. So if you do that, all the denominators cancel and you're left with just the top, which is the same thing we get here. Or if you want, you can combine them as one fraction first and then multiply by the denominator so that they cancel and they get here. All three of these will get you to the same spot. They just are different ways depending on how many steps you want to write or what steps make sense. And this actually here is the same thing that we got right here, but we did it in a different order, and this actually comes out exactly the same. So we got to the same spot. It just looks a little different because we did the multiplication, but we got to the same thing. So you have different choices here of when you want to multiply by the common denominator based off of just what works for your brain. So, but you get to the same answer and then you can go and solve. So that's why I kind of made this tree to show you the different steps. This one here is the fastest, but I think it's the one that's prone to the most errors. I think the one that people make the least amount of mistakes on is to do it this way, which is more steps, but you're less likely to make mistakes. So it's up to you on which one you want to do.